Hey guys, and welcome back to my channel, the Nexus-Stack. And on today's video, we're going to discuss about the Rust ownership. What is its importance? Why do we need it? What are different types of Rust ownership systems? And all together that explained with example itself. So I request you to watch the entire video till the end. But before we go on to any further, let's first understand what is mutability. Well, mutability, as the name sounds, is a way to define or to set a standards of how things will change, how something will going to change a state, a value, or properties at any time inside your program, specifically in this context. So, mutable data are mutably borrowed. This is called mutability, and whether a data is mutable or not is defined by mutability. That's the most simplest way I can explain it to you. Now let's understand why do we need it. Now the major reason why we use mutability in this Rust programming system is something has to deal with a key issue that was not addressed correctly back in some of the much more lower levels of the system programming languages like C, C++, Cobalt, that their fundamental structure doesn't allow the type that mutability offers them. Basically, how you are going to change a value inside the memory is one of the big reasons for all the bugs. And if not handled correctly, obviously it's going to result in an error or potential bugs that your program will gonna have. So to address these types of issue about the manipulation of the value, or to store a value or retrieve a value, change it, anything that you have to do with the value itself, mutability gives you all of that comfort, and it defines a standard set of norms to handle it. So this is why we use mutability. Alright, so now we'll take a look on the practical example to understand what exactly mutability is under a typical condition. So let's suppose you define an object which holds an integer value and its name is underscore immutable binding, and you add another variable whose definition contains a modifier mute before it, which is a specifier that this object is mutable. That means it can change this value dynamically throughout the program, and it's legally allowed to do it, whereas the above underscore immutable binding is not allowed to do it. Now after defining these objects, we'll now do a simple task of getting that value on our console on our standard output, where we'll print the value of both the immutable binding, and after printing that operation, after committing that operation, we'll try to modify and observe how it will work. So what error message will it going to give to us, and how that thing will react if we do it illegally without adding a mutable modifier right above it. Whereas if we do the same operation for mutable binding, that would gonna result in no error and would compile very, very fluently without any errors popping out or any message coming on the terminal that it is incorrect. So as you can see on the screen, that after we define println macro, which is a macro to specify print function on the console, and we print out the mutable binding value to it. So after printing that out, we will increment the value of the mutable binding by one step here. And now this step is not a typical byte step. That means how much bytes we add to the existing object value. It is actually integer value, so this will gonna add a integer value to the existing object mutable binding, and we'll reprint that same object from the println macro, and we'll get the output to be the same modified mutable binding, which in this case will be 2. Now if we try and do the same thing for the underscore immutable binding, that would gonna result in an error, as I told you previously, because that is not specifically allowed to do it, because that immutable binding object doesn't contain a mutable modifier placed right in between the let and that object name itself. So once we compile it inside our console, we will observe that there is an error. We try to execute it, and that's essentially what will happen to. So if for the purpose of understanding, if we try to execute that program again, it will going to point something like this, where it will tell you the fix me comment. It will highlight this entire line with a specific address, specific specifier on the console, and will indicate to you that you have done a mistake on this line. Now let's look on practically on a console. So we'll first type cargo run, and after that we'll compile, and as I told you, you'll get an error. That error, by the way, is of comment, so it has nothing in correlation to what I've told you previously. That was my fault. I was a little reckless in knowing what I have to add there, so I will just do the same thing again. And after fixing that error, you will see perfectly that it is pointing out the entire statement to be illegal with the red mark and cannot assign the twice to the immutable variable. So that value reassignation is completely abandoned to it. Now we'll add the mutable variable here, and we'll save the file again, and afterwards we'll go to the console. And once we are there in the console, we'll see what happens next. So it will say, voila, that's it. It compiled successfully. So you must have got a clear picture about what exactly mutability does to an object's lifecycle, and how does it modifies the certain default properties of the object. Thank you so much for watching this video, and if you have some comments and suggestions, you can post them down in the comment section below.